Hello everyone, I'm Hong Yu from Fitchburg State University. Today I will give it to you demo for our project. This project supported by the main project grant and the faculty and the student grant of Fitchburg State supported. Now I will introduce my student Elijah to give you guys explain this project.
Hello, my name is Elijah. I'm a student here at Fitchburg State. I'm in the electronics engineering major. If you want, I can explain some of the software first. So over here we have our temperature limits, so we can set a high limit and set a low limit with sliders here or numeric input down here. And we get our graphical readout here, and we have an instant digital readout here of our temperature. Then we have our carbon monoxide limit. We can set that with this slider or numeric input down here. We have our instant readout parts per million and our instant readout voltage from our sensor. We have the same thing as temperature with our relative humidity. We have our sliders here to control high limits and low limits. And then we have numeric inputs to control the same thing. And then we have an instant digital readout of percentage of relative humidity. Over here we have our different channels, so we can control our LEDs and read our sensors. And up here we have a switch to switch between numeric input and our sliders on our program. So I can demo the hardware now. So on this side right here, this red LED is our carbon monoxide alert LED. It turns on when we reach our alert parts per million. These three LEDs, green, yellow, and red, are our humidity LEDs. So green on the left is our high limit, yellow in the middle is optimal, and red on the end is our low limit. They'll light when it meets certain conditions. And then our temperature is laid out the same way. Left is too high, middle is optimal, and right is too low. Over here is our carbon monoxide sensor, and over here is our temperature sensor. And I can demo our temperature. Right now it's sitting in optimal. As you can see, the middle LED is lit, and when I grab this, it should warm up the sensor and should trigger our high based on our settings in our software. You can see that it switches over to high LED. And you can see over here in the software, we have an instant readout of 82 as opposed to, I believe it was 75-ish before.
Okay, you release.
I let go, and the temperature drops, and it should go from optimal to too low.
Okay.
In the future, we are planning on changing our temperature sensor out for IR sensors, so we can detect when people are in a house or not, and our LEDs will be changed into relays, so we can control things like AC and heat in the house, depending on who's home or not.
Thank you. Thank you.